Namaste, Vanakkam, and welcome back to Midha Guru. Before beginning, have you watched Trigonometry Part 1 and 2 on our channel? If you haven't, I'd like to request you to go to our channel and watch both of them, then come to this video. And if you have already watched them, well, welcome to some applications of trigonometry. Well, what if I told you that you could calculate the height of a tree without using an inch tape in your notebook based on the angle of elevation of the sun and the length of the shadow of the tree? That would be surprising, wouldn't it? Well, this chapter deals all about heights and distances and how we can calculate any one of them based on the other and the angle in context. Well, without further ado, I, Manan Matthew, the math faculty here, would like to take you into this lesson. So let's begin it. So students, before we begin the lesson, let's see what our learning objectives today are. The first is to understand this concept of heights and the distances and how to apply them in our problems. The second is applying the knowledge of the t ratios that we learnt in the earlier lesson and how to apply them in this particular topic of applications. In the next, we'll understand what are the different types of problems or concepts that this idea of heights and distances deals with. And the last is we'll understand how to solve problems based on all this knowledge that we'll gain today. Well, let's get into the lesson. But before that, if you haven't yet liked this video, please do that. And if you haven't yet subscribed to our channel, please go ahead and do that. And so, let's get into the lesson. As you all know, we had a festival quite recently known as Makar Sankranti. You know what it's famous for? Well, yes, dahi chuda and tilkut, but also flying kites. Now, when I was a kid, I had this great idea of how to calculate whose kite was flying higher, because it was always a topic of argument between us friends. So what I did was I measured the length of my rope to my kite, and somehow as a kid, that's what I thought was the length or the height that my kite was reaching. But there was a fatal flaw in this idea. This is not the height of how high my kite is flying. So when I moved further on in my studies and I reached a higher class, I got a better understanding of this. So to calculate how high my kite was flying, I started applying the knowledge of t ratios. If only I knew this angle, let's name it theta, and any one of these three directions, that is either the length of the string, the lateral distance that the kite was from me, and the height that it was above the ground. As I told you, I knew this length. I measured it to be somewhere around 20 meters. Now, if this angle is 30 degrees, then what would the height of my kite be? Well, as you know, we can calculate the sine of theta by dividing the perpendicular by the hypotenuse. I do not know the length of the perpendicular, but what I do know is that the angle here is 30 degrees. So if I say sine 30, and if you have watched the video of trigonometry, you will know that this is equal to 1 over 2. And I do not know the length of my perpendicular. Let's name this triangle as ABC. Then sine of this particular angle theta, which is 30 degrees as we know, would be AB by the hypotenuse AC. Now we know that sine 30 is 1 by 2. And we don't know the length of AB, but we do know the length of AC, which is 20 meters. So now AB will be equal to 20 over 2, that is 10 meters. So this is how I found out how high my kite was flying. This logic can be applied to a lot of different topics in trigonometry. Let's understand the basics one by one. On a clear Monday morning in June, Ravi decides to visit a field nearby his house. While he's walking around listening to his music, he sees a plane flying up in the air. Think about that for a moment. Can he see the plane if he keeps his vision level? No, he has to move his eyesight in the upward direction. Well, such a case is known as the angle of elevation. The angle formed between the horizontal line of sight and the line of vision to see a targeted object, this angle here is known as the angle of elevation. Let's understand that in a bit of depth. Let's say on a level ground, a person is standing at some arbitrary distance from a huge banyan tree. Now while he is looking at the tree, on a particular branch, he sees a very beautiful bird. What happens if the person looks straight, that is, along the horizontal line of sight? He'll only be able to see the bark of the tree or some leaves hanging down. He won't be able to look at the bird directly, right? To look at the bird, he must move his vision upwards, that is, in the anti-clockwise direction, right? So the angle formed between the horizontal line of sight and this line of vision that he has to move his neck or his eyes to look at the bird directly, this angle here is known as the angle of elevation. Angle of elevation comes into play anywhere where the targeted object or person is above the viewer, that is, at a point higher than the viewer. Let's move on to the next type of angle with this topic, that is the angle of depression. On a sea beach, there's a huge lighthouse, and Sumitra climbed up that lighthouse. Now when she was looking straight, she could see the beautiful sky and the clouds. When she looked down, she could look at a small boat approaching this particular beach. Stop here and think for a moment. What would she have to do to look down at the boat? Exactly, she had to move her line of sight downwards from the horizontal. In a case when the target or the object that we are supposed to be looking at is downward from the line of the horizontal, that it is lower at a lower height than us, we call the angle so formed between the line of sight and the horizontal line the angle of depression. Let's understand in a little bit more detail. Now if I tell you I'm standing on the top of a building and my friend just arrived by my house. To look at my friend, if this is the horizontal line of sight and this is where my friend is standing, I must look downwards, right? Well, so when I move my eyesight downwards, the angle so formed with the horizontal line of sight is known as the angle of depression. This kind of theory deals with any type of problems in which the object or the thing that is supposed to be looked at or targeted is below the horizontal line of sight. That is, it is at a lower altitude than the person in context. Well, what happens when we combine them both? That is, we combine the angle of elevation and the angle of depression. Let's see and try to understand. So on a lone barren desert, an astronaut lands out of nowhere and he gets on top of this building. Now when he sees the other building on the other side of the street, he sees that it is particularly taller than the building that he is standing on. But as he is at a particular height, to look at the bottom of the building, he has to look downwards. But to look at the top of the building, he has to look upwards. Do we deal with this whole angle as one? No. We draw a horizontal line. The angle at which he looks at the top of the building with the horizontal line of sight, let's name that theta 1. And the angle formed when he has to tilt his head downwards to look at the foot of the building from the horizontal line of sight, let's name that as theta 2. Here in this case, theta 1 is the angle of elevation and theta 2 is the angle of depression. And to calculate the height of this building or the distance between these two buildings, that is the width of this street, we'll have to use both these concepts. Let's understand a little bit deeper. Let's imagine I am standing on the top of a cliff. If you don't know what a cliff is, it's kind of a rocky edge which drops all the way down suddenly. And here at the bottom of this cliff, there's a beautiful lake. A fish is swimming in this lake. And there's a bird flying up top here. What do I do to calculate the vertical height between this bird and this fish? To look at the bird, I must look upwards. And to look at the fish, I must look downwards. Do I treat this angle as 1? As I told you earlier, we draw the horizontal line of sight. This angle will become the angle of elevation. Let's name that theta 1. And this angle that my head makes to look at the fish from the cliff, let's name that as theta 2, is the angle of depression. On solving trigonometrically both these triangles, I will get the vertical height between these two, that is the bird and the fish. Let us move on and see what all this knowledge applies to in the mathematical sense and in our daily life. Now let's say a company has to make a ropeway to climb a particular mountain. That is, for tourists to climb a mountain and see its height. Let's say this is the mountain and this is the plain land from where the ropeway needs to start. To do this, the company that must build the ropeway must have a fair idea of how high this mountain is and what kind of angle at which the ropeway can pull the cabin upwards. Let's say that the company that is making the ropeway only deals when the angle is at least 30 degrees or not more than 30 degrees. In either case, let's say that this angle of elevation is 30 degrees, that is theta is equal to 30 degrees. So, how long will be the ropeway on which this cabin will be carried upwards? For this, all he has to do is calculate the sine of this particular angle theta. As you know, the side facing this angle in context will be the perpendicular, and the perpendicular divided by the hypotenuse will give us the value of sine theta, that is both will be equal. In that way, the company can calculate the length of the rope required to make this particular ropeway. Let's understand a few more applications. Let's say you are a police sniper and terrorists are approaching your building. They are in a Mahindra Jeep. That is, they are approaching from this angle directly in the direction of your building. When you were looking at them when they were here, the angle of depression so formed was 30 degrees. After a few minutes, the Jeep reached somewhere here, and when you look down again, this new angle of depression was 60 degrees. How can you find out what the speed of this vehicle is? Well, let's say it moved 10 meters in a time of 20 seconds. But how did we come to know that this distance was 10 meters? The first place, what I know is the height of the building that I am standing on. The second is I have a fair idea of the angles that the vehicle is making in this gap of 20 seconds. Well, in the first, I will calculate the length of this perpendicular. Then I'll be able to calculate the hypotenuse or the lateral distance, whichever I need to calculate. I will know exactly how far in the lateral direction is that Jeep from my building. After 20 seconds, again applying the T ratios for the value 60 degrees, I can find out the lateral distance that the car is now from me. Now, given that it traveled 10 meters, I can calculate that it is traveling at half a meter per second. But to calculate this 10 meters will require a basic knowledge of trigonometric ratios. So now that we have understood a fair bit of these concepts, let's get into exercise 9.1 that is in your NCERT books, and if you can start solving with me, it will be great fun. Let's get into the exercise. So if you can open your NCERT textbooks to exercise 9.1, we'll start solving these problems. The first one says that a circus artist climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degrees. Look at this triangle for just a second. What did we discuss? If this is the horizontal line, as we know it's a straight line with the horizontal, or it depicts the ground that is even, this angle formed here, what will be its name? Yes, it's called the angle of elevation, as the line of sight to see the top of the pole moves upwards. Now we know that the length of the rope here, or in this triangular case the length of the hypotenuse is 20 meters. We are supposed to calculate the length of AB, which is nothing but the height of the pole. How can we go about this? Well, we do know a relation between this angle and the side that is facing. this would be the perpendicular of this particular triangle in context of this angle C, that is 30 degrees. And we know that the hypotenuse is 20 meters. A relation that links the perpendicular to the hypotenuse is the sine, that is the trigonometric ratio sine. Now sine of 30 is equal to 1 over 2, which means and also we know that by trigonometric relations, the perpendicular over the hypotenuse is what gives us the value of this particular sine. So sine 30 is also equal to AB over AC. As the left hand side of both these equations are the same, we can say that these both are equal. So AB over AC is equal to 1 by 2. Now we know that the length of AC is 20 meters, so we'll just substitute that here. We get AB by 20 is equal to 1 by 2. So AB will be equal to 20 divided by 2, which is 10 meters. So the length of this pole to which the rope is tied is 10 meters long. Let's move on to the next problem. Well, coming to the next problem, it says a tree breaks due to a storm and the broken part bends so that the top of the tree touches the ground, making 30 degrees with it. The distance between the foot of the tree and the point where the top touches the ground is 8 meters, so find the height of the tree. Well, many of my own students had particular problem with this very question. That is, they were not able to understand what this problem is asking. If a little bit of visualization would help you, look, there's a tree and after the storm, it breaks down in such a way that it's not completely detached from itself, but it bends down and touches the ground. To put this into a geometrical sense, if we make a triangle where this side is the leftover height of the tree, this side is the part of the tree that is somewhat broken and touching the ground, and this is the distance between the top of the tree and the foot of the tree. Let's name this triangle as ABC. Well, according to the question, the distance between the top of the tree and the foot of the tree is 8 meters, and this angle that this particular broken part is making with the horizontal or level ground is 30 degrees. This is what a figure of this particular problem would look like. To solve it, so now this triangle ABC, in which angle C is 30 degrees and BC is equal to 8 meters. We are supposed to find the height of this particular part. The question asked us to find the height of the tree, but that doesn't mean just this height. After calculating this, we must also calculate the hypotenuse so that we'll be able to understand what the height of the actual tree when it wasn't broken was. So first, to calculate this side or the perpendicular with context to angle 30, we know that a T ratio linking the perpendicular to the base is tangent. So tan of 30 in this particular triangle will be equal to the perpendicular, that is AB, over the base, that is BC. We know that AB we don't know, we know it as P, and we know that BC is 8 meters. We'll leave it at this. We also know that the tangent of 30 is 1 over root 3. If you don't know how I easily wrote this down, go back and watch Trigonometry part 1 and 2 to understand better how you can calculate this or the T ratio of any of the common or specific angles that we deal to in most problems. Coming back, now as this both are tan 30, we can say that P by 8 is equal to 1 over root 3. So P by 8 is equal to 1 over root 3, or the perpendicular will be 8 divided by root 3. So the value of root 3 is somewhere roughly equal to 1.732. We'll use that value to do this division. So leaving it at 2 decimal points, we get that the length of this perpendicular is roughly 4.61 meters. Now to calculate the length of this hypotenuse, I could either use the Pythagoras theorem or I could simply calculate it by using one of the other t ratios that links the perpendicular to the hypotenuse, that is sine. Now for this angle 30, I know that the sine is equal to 1 by 2. But I also know that by trigonometric relation, sine 30 will be equal to the perpendicular, that is AB, by the hypotenuse, that is AC. So now half is equal to AB, which we know the length is 4.61 meters, divided by AC, which we don't know. So AC will be equal to 4.61 into 2, which will be equal to 'So now we know that the length of this perpendicular is 9.22 meters. And the length of the hypotenuse is 9.22 meters, and the length of the perpendicular, as we calculated earlier, is 4.61 meters. So the height of the tree will be equal to 9.22 plus 4.61, which will give us, this will be the approximate height of the tree that we were discussing about. In the next problem, if we read, a contractor plans to install 2 slides for the children to play in a park. For the children the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meters and is inclined at an angle of 30 degrees to the ground. Whereas for the elder children, she wants to have a steep slide at a height of 3 meters and inclined at an angle of 60 degrees to the ground. What should be the length of the slide in each case? To understand this, let's draw 2 triangles. One is for the slide that the contractor plans to build for the kids of age 5 years or around, and one for the elder kids. She says that this angle should be 30 degrees and this height should be 1.5 meters. And in the slide for the elder kids, this angle is 60 degrees and the height would be 3 meters. So now we are supposed to calculate the length of the slide, or to put it in context, length of the hypotenuse in both these triangles. Let's solve for the kid slide first. Now as you know that in context to this angle 30 degrees, this is the perpendicular. To calculate the length of the hypotenuse, I must just use the relation of sine. Sine 30 is equal, as you know, to the perpendicular divided by the hypotenuse. If I name this triangle as ABC, and let's name this triangle as DEF. Now in ABC, the perpendicular is AB and the hypotenuse is AC. I know that sine 30 by value is 1 by 2. Now I know the length of AB is 1.5 meters and we do not know the length of AC. So AC will be equal to 1.5 into 2, that is 3 meters. So the length of this kid slide would be 3 meters. Now to calculate the length of the slide for the elder children. Again, we know the length of the perpendicular here, that is 3 meters, and we must calculate the length of the hypotenuse. Let's go about this. Again, using the same relation of sine, but for this angle 60, we will get that sine 60 is equal to the perpendicular, that is DE, divided by the hypotenuse, that is DF. Now by value we know that sine 60 is equal to root 3 by 2. The length of DE is 3 meters and that of DF is unknown. So to calculate the length of DF will be equal to 3 into 2 divided by root 3, which we can cancel out as root 3 into 2, which will be equal to So the length of this elder children's slide will be roughly equal to 3.464 meters. Now moving on to the next problem. Now in this next problem, the angle of elevation of the top of a tower from a point on the ground, which is 30 meters away from the foot of the tower, is 30 degrees. Find the height of the tower. It says there's a tower as such. We do not know the height of the tower, but we know that from a point on the ground that is 30 meters away from it, the angle of inclination to look at the top of the tower is 30 degrees. Using this data, we must calculate the height of said tower. Let's say the tower is AB and this point is C. So as you can see in this triangle, given with context to the angle 30 degrees, this side AB is the perpendicular and this side BC is the base. Again, a T ratio that links the perpendicular to the base is the tangent. That is, the tan of 30 would be equal to AB divided by BC. Now, by knowledge of the trigonometric values, I know that tan 30 is 1 by root 3. If you don't know how we arrived at this, go back to trigonometry part 1 and 2 on our channel Midha Guru. Watch those videos to understand better how we can calculate these values very easily. Coming back to the problem, now I know the length of BC, that is the base, and I'm supposed to find the height AB. So AB over 30, which is the value of BC. So AB, or the tower, is equal to 30 over root 3. I can write 30 as 3 into 10, and root 3 will cut root 3 times. So AB will be equal to 1.732 into 10, which is roughly equal to 17.32 meters. This would be the length of the tower that is discussed in this particular question. Moving on to the next question. This next problem is much to my liking. As I already told you, I'm very much fascinated by kites. So kite is flying at a height of 60 meters above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degrees. Find the length of the string assuming there is no slack. First of all, what is the meaning of this slack? It means that if the kite is flying at a height somewhere here, the string is not slacked in this way. It is straight without any lag. Anyways, if I name this triangle as ABC, this is the perpendicular height of the kite with respect to the ground. This is the lateral distance between the point C and where the kite is flying overhead, and this is the length of the string, that is the hypotenuse. Now all that is given to us in the question is that it's flying at a height of 60 meters and the angle formed is 60 degrees. We are supposed to calculate the length of the string. Now in this triangle, with respect to angle 60, the side AB, or the perpendicular height of the kite, is the perpendicular, and the length of the string, that is AC, is the hypotenuse. A T ratio that links both of them is sine. The sine of 60 could be written by the perpendicular divided by the hypotenuse. We know the length of the perpendicular is 60 meters, so we just write down that 60, and we do not know the length of the hypotenuse. And I also know that the value of sine 60 is root 3 by 2. So AC would be equal to 60 into 2 divided by root 3. I could write 60 as 3 into 20, and root 3 will cut root 3 times. So I get AC is equal to 40 into root 3, which will be equal to So the length of the string will be roughly equal to 69.28 meters. That is, this side, the hypotenuse, will be 69.28 meters. Moving on to the next problem. Coming to this next problem, it says that a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. So find the distance he walked towards the building. Well, to put this into a diagram, this is the building that is 30 meters high. Now this boy is standing at some distance from the building. But when he looks at the building, he does not see the foot. He sees actually a height 1.5 meters from the foot, because he is 1.5 meters tall himself. So the triangle changes a bit. this is the 30-degree angle that the question talks about. Now when he moves towards the building, a new angle of 60 degree is formed. We are supposed to calculate this distance that he walked towards the building. So now if I draw this triangle again, if the whole building was 30 meters tall and the boy himself is 1.5 meters tall, that means he sees at a height of 1.5 meters from the foot of the building, which means now the effective length of the building decreases from 30 and becomes 28.5 meters. This angle here is 30 degrees, and when he moves closer to the building, it becomes 60 degrees. Now if I name this triangle as ABC and this point as D, I know that this is the perpendicular in both the triangles ABC and ABD. To calculate the length of BC first, let's concentrate on the triangle ABC. We know that this is the perpendicular and this is the base. So the relation of the tangent is the perpendicular divided by the base. We know that tangent of 60 is equal to root 3. AB is 28.5 meters and we are supposed to calculate the length of BC. BC will be equal to 28.5 divided by root 3. To do this division, just write down So we'll just leave it at this. We will get that BC is equal to 16.4 meters. Now, coming back to the larger triangle ABD, in a similar fashion, the tangent of 30 will be equal to AB over BD. Now I know the tangent of 30 is 1 by root 3. The length of AB is 28.5. So to calculate the length of the BD, it will be equal to 28.5 into root 3. To do that, we get that BD is equal to 49.36 meters. Now to calculate the length of this DC, which is the length that the boy walked towards the building, we can calculate it by doing 49.36 minus the length of BC, that is 16.4 meters. We will get so the boy walked 32.96 meters towards the building, and that is how the angle of elevation changed from 30 to 60. If you didn't understand this problem, let me just know in the comments below so that I can explain it to you better. Now moving on to the next problem. In this next problem it says that from a point on the ground, the angles of elevation of the bottom and the top of a transmission tower fixed at the top of a 20-meter high building are 45 and 60 degrees respectively. Find the height of the tower. Let's understand what this question is asking. It says there's a building that is 20 meters high and there's a transmission tower fixed on top of it. So for any person standing on level ground, the bottom and the top of this tower, question says the tower, not the building, they both are elevated, right? So to put this into the triangular sense, if this is the bottom of the tower, this is the top of the tower. If I name these points as A, B, C and D, the angle BCD is 45 degrees and the angle ACD is 60 degrees. Now the length of BC, that is the height of this building, is 20 meters. So before we do anything, let's calculate the length of this base. it says that this angle of elevation to the foot of the tower is 45 degrees. So I can apply that the tangent of this angle will be equal to the perpendicular divided by the base. I know that the tangent of 45 is 1. The length of BC is 20, and so DC will also be equal to 20 meters. Now, coming to the larger triangle ACD, the angle of elevation is 60 degrees. So the tangent of 60 must be equal to the perpendicular, that is AC, divided by the base, that is DC. I know the tangent of 60 is root 3. AC we do not know yet, and DC is equal to 20 meters. So AC will be equal to 20 into root 3 meters, which I will get as will be equal to 34.64 meters approximately. That is, the height of the building along with the transmission tower is 34.64 meters. Now to calculate the length of the tower, that is AB, what I'll do is AC minus BC will be equal to AB, right? So we know the length of AC is 34.64 meters and the length of BC, or the length of the building, is 20 meters. So the length of AC will be equal to 14.64 meters. So this transmission tower is 14.64 meters long. So now moving on to the next problem. In this next problem, it says that a statue 1.6 meter tall stands on the top of a pedestal. If you don't know what a pedestal is, it is sort of a decoration thing made for statues, flower vases, flower pots. It's a raised platform sort of thing on which we keep something of decoration. Then from a point on the ground, the angle of elevation of the top of the statue is 60 degrees, and from the same point the angle of elevation of the top of the pedestal is 45 degrees. Find the height of the pedestal. It's quite similar to the problem that we solved earlier. Let's look how. If this is the pedestal and the statue stands here, the statue is 1.6 meters tall. And when I look at the top of the statue from a point on the ground, level ground, it's 60 degrees, and the angle of elevation from the top of the pedestal or the foot of the statue is 45 degrees. To draw a neater diagram, this length is 1.6 meters, this whole angle is 60 degrees, and the smaller angle is 45 degrees. Again, on naming this triangle as ADC and BCD, in the triangle BCD or in the triangle ACD first, I will know that tan 60 is equal to the perpendicular divided by the base. That is AC divided by CD. Now I know that root 3 is the value of tan 60. AC is nothing but 1.6 plus BC divided by CD. So BC is equal to root 3 times of CD minus 1.6. Let's leave this equation right here. Now I know that the tangent of 45 degrees is the perpendicular BC divided by CD. Now tangent of 45 is 1, so BC by CD will also be equal to 1, so BC is basically equal to CD. So instead of writing this CD here in equation 1, I'll just substitute it what we just learnt about. We'll say that BC is equal to root 3 times of BC minus 1.6. If I bring this BC to this side of the equation and take this 1.6 to the other, I get that root 3 BC minus BC is equal to 1.6 meters. Moving ahead, 1.732 times of BC minus BC is equal to 1.6. So So the length of BC is roughly equal to 2.07 meters. BC, if you can remember from the diagram, was the length of the pedestal. That was what we were supposed to calculate. Moving on to the next problem. So this next problem says that the angle of elevation of the top of a building from the foot of a tower is 30 degrees and the angle of elevation of the top of a tower from the foot of the building is 60 degrees. If the tower is 50 meters high, find the height of the building. The question means that there are two things. There is one building and a tower. The tower is 50 meters high. Now the angle of elevation of the top of the building from the foot of the tower is 30 degrees and the angle of elevation of the top of the tower from the foot of the building is 60 degrees. We are supposed to find the height of this building. How do I know that the tower is higher? Why did I draw it higher? Well, if both are on level ground, then from the foot of the tower, if the angle of elevation is 30, and from the foot of the building, if the angle of elevation is 60, this means that from here I have to look higher, which means that the tower would be higher than the building. Well, let's get into it. How am I supposed to solve this? For this, let's name these triangles as A, B, C and D. AB being the tower and DC being the building. BC being the distance between them. Well, in the triangle ABC, tangent of 60 would be equal to this perpendicular AB divided by the base BC. Now tangent of 60 can be given by root 3 and I know that AB is 50 meters. So the distance between the two buildings, that is BC, would be 50 divided by root 3. And doing this calculation I would get So now I got that BC is equal to 28.84 meters. Now to calculate the height of this tower DC or the building DC, let's consider the triangle BCD. The tangent of 30 will be equal to the perpendicular divided by the base, that is DC divided by BC. Now tan of 30 I know is 1 by root 3. I don't know the height of DC, so I write DC. BC can be given as 28.84 meters. Instead of this, if I just write down DC will be equal to 50 by root 3 divided by root 3 will be equal to 50 by root 3 to 1 by root 3 is 50 by 3, shall be getting 16. So the height of this building DC is equal to 16.666 meters. So let's move on to the next problem. So now in this next problem, two poles of equal heights are standing opposite each other on either side of a road which is 80 meters wide. From a point between them on the road, the angles of elevation of the top of the poles are 60 and 30 respectively. Find the height of the poles and the distance of the point from the poles. This is a bit of a vast question. Let's see what it means. This says that this road is 80 meters wide. There's a tower on this side and there's a tower or a pole on this side as well. Now at some arbitrary point here, the angle of elevation of one of the towers is 60 degree and the other tower is 30 degrees. Sorry if my drawing is bad, I didn't take drawing classes as a kid. Anyways, now if this entire length is 80 meters, let's say this is at a distance of x meter from the point. So the other would be 80 minus x meters. Now let's name this triangle as ABC and this triangle as CDE. In the triangle ABC, the tangent of 60 is equal to AB divided by BC, that is the perpendicular divided by the base. We know the tangent of 60 is root 3. We do not know the length of AB. We leave it just as it is. And this is 80 minus x. So root 3 into 80 minus x is equal to AB. Let's leave it here. Now coming to this triangle DCE, the tangent of 30 would be equal to DE divided by CE, which is nothing but perpendicular divided by the base. Tangent of 30 can be given by 1 over root 3. Now we do not know the value of DE, but we do know that C is equal to x. So DE will be equal to x over root 3, or x is equal to root 3 times DE. Now as we have two equations dealing with x, what we'll do is we'll just substitute the value of x here in this equation. So we will get root 3 80 minus root 3 DE is equal to AB. The important part that we missed out is that both these poles are of equal height, which means that we can replace DE by AB or vice versa. When we open this bracket, we'll get root 3 into 80 minus root 3 into root 3 times DE will be equal to AB, or we can write it as DE. For the solving, we get root 3 of 80, multiplying this we get 3DE is equal to DE. Moving this to the other side, we will get root 3 into 80 is equal to 4 times of DE. Just remember this. Moving on, we will get root 3 times of 80 is equal to 4 DE. So DE is equal to root 3 into 20, which will be equal to this will be the approximate height of tower DE, and also as both the towers are of same height, AB will also be equal to 34.64 meters. Now we can use any of the two triangles to calculate the distance that the point is placed at between those two towers or poles. Let's use the triangle CDE that we drew. We wrote that tan 30 was equal to DE divided by the length x, that was CE. Now we know that tan 30 is 1 over root 3, and as we have calculated this length of D, let's just leave it as it was, that is root 3 into 80, or my mistake, root 3 into 20 over x. So x will be equal to root 3 into 20, or 3 into 20, which will be equal to 60 meters. Now it's said that the road was entirely 80 meters tall, and we drew this point at some distance x that we named as CE, and this other was 80 minus x. Now if x is equal to 60 meters, then the distance of the other pole from the road, or this point on the road, would be 20 meters. This is how we'll solve this particular problem. Moving on to the next one. In this question, it says that a TV tower stands vertically on the bank of a canal from a point on the other bank directly opposite to the tower. The angle of elevation of the top of the tower is 60 degrees. From another point 20 meters away from this point, on the line joining this point to the foot of the tower, the angle of elevation of the top of the tower is 30. Find the height of the tower and the width of a canal. Now I have drawn a rough diagram here already. This is the telephone tower that the problem is speaking about. Let's say this BC is the canal. On the opposite side, just if we stand here, we see that the top of the tower is at an angle of elevation 60 degrees. And when I move at a further point away D in the same straight line, the angle of elevation from here is 30 degrees. Now I am supposed to find two things. I am supposed to find the height of this tower, and I am also supposed to find the length of this or the width of this canal. And the only detail that I am given is that the distance between these 2 points is 20 meters. Look at the question for a bit and try to understand what we are supposed to do here. If you can remember, in a few problems ago, we are supposed to calculate this very part of a similar type of problem. We'll just use that kind of logic here as well. If in this triangle ABC this angle is 60 degrees, I know that the tan of 60 can be given by the perpendicular divided by the base, that is AB by BC. Now we know tangent of 60 is root 3, and I bring BC to this side, I get that AB is equal to root 3 times of BC. Now coming to the next part. In this bigger triangle, that is ABD, the tangent of 30 would be AB by BD. Which is 1 by root 3. Now instead of AB, I'll write down root 3 BC. And instead of BD, I will write BC plus 20. If I multiply this root 3 here and bring this BC to this side, I get that BC plus 20 is equal to 3 times of BC. So taking BC to the other side, I get 20 is equal to 2 BC. So BC will be equal to 10 meters. This distance here will be 10 meters. Now substituting the value of this 10 over here, I will also get the length of this tower. So as AB is equal to root 3 times of BC, so AB will be equal to 1.732 into 10, which is roughly equal to 17.32 meters. That is, the height of this tower will be 17.32 meters. Now moving on to the next problem. In this next problem, it says that from the top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 and the angle of depression of its foot is 45 degrees. And we are supposed to determine the height of the tower. Well, there are few things that you must deduce right away after reading the question. That is, that if I am at the top of this building and as it says angle of elevation, which means that I must move my eyesight above from the horizontal line. This would mean that the cable tower is in fact higher or taller than the building in discussion. Moving on, if this is my 7-meter high building, from the top here at an angle of 60 degrees is the top of my tower, and to look at the foot of the tower I must look at an angle of depression of 45 degrees. Now if the building and the tower are both on level ground, this would mean that from this point here, if I name this as B, C and D, if AC is a straight line, this would mean that A, and let's name this point as E, AE is equal to CD. That means this part of the tower is 7 meter high and we must find the rest of the length. Well, in the triangle ACD, as this is the angle that is considered, this would be the perpendicular and AC would be the base. Now tangent of 45 will be equal to the perpendicular, which is CD, divided by the base, which is AC. Now I know tan 45 is 1 and I know that CD is equal to 7 meters. So divided by AC, this would mean that AC is equal to 7 meters. So this AC is 7 meters. That is, the horizontal distance between the two buildings, or the building and the cable tower, is 7 meters. Why did I calculate this 7 meter, you may ask? It is to ease my calculation of BC. Now in the triangle ABC, tan of 60 would be equal to the perpendicular, that is BC, divided by the base, that is AC. Now I know that the tangent of 60 is root 3. So BC by, and AC we calculated as 7 meters. So BC will be equal to 7 into root 3. On doing this calculation, I will get that BC is equal to 12.124 meters. So the height of this entire cable tower, that is BD, would be equal to 12.124 plus 7, which will give us 19.124 meters, which is approximately the height of this cable tower. So moving on to the next problem. Coming on to the next question, it says that as observed from the top of a 75 meter high lighthouse from sea level, the angles of depression of two ships are 30 and 45 degrees respectively. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. Well, let's draw a rough diagram. Let's say this is the lighthouse from sea level and the sea starts from somewhere around here. This height is 75 meters. Now from here, the angle of depression of two ships are to be calculated. As you can see that it is 30 and 45. Which of these angles do you think is 30 degrees? Well, it would be the smaller angle, right? Very good. And this whole angle would be 45 degrees. If I name this as A, B, C and D, in the triangle, and I name these points as E and F. Now considering the triangle ACF, I know that the tan of 45 is EC divided by AE. So writing that down, tan of 45 in this particular case would be the perpendicular divided by the base. Now what would be the length of EC? If this is the horizontal line and it's a straight line, this would mean it is equal to this height. So EC will also be equal to 75 meters and so will be FD. If we substitute all these values that I know, which is tan 45 is 1, EC is 75. So then AE would be equal to 75 meters. Now coming to this triangle ADF. In ADF, the tangent of 30, that is this angle here, is equal to the perpendicular divided by the base. That is DF divided by AF. Now I know AF is the combination of AE and EF. And according to the question, we are supposed to calculate the distance between the two ships. That is EF, which will be equal to CD. Now, I know tan of 30 is 1 by root 3 and DF is 75. And AF will be 75 plus the length of EF. So I get that 75 plus EF is equal to root 3 into 75. And doing this calculation, I'll get that 75 plus EF is equal to 129.9 meters. So EF would be equal to 129.9 minus 75 meters, which will be equal to 54.9 meters approximately. This means that the distance, that is the lateral distance between the two ships with respect to the lighthouse, is 54.9 meters. Moving on to the next problem. In this next question, it says that a 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height of 88.2 meters from the ground. The angle of elevation of the balloon from the eyes of the girl at any instant is 60 degrees. After some time, the angle of elevation reduces to 30 degrees. Find the distance travelled by the balloon during the interval. That means we are supposed to find this lateral distance that the balloon moves in this interval. Now, the entire height, that is the height of the balloon from this ground here, is 88.2 meters. And the height of this girl up to her eye line is 1.2 meters. This would mean that the height of the balloon with respect to the girl would be 88.2 minus 1.2, which is 87 meters. Now, we are supposed to calculate the lateral distance between the two positions of the balloon. Now, if I name this triangle as ABC and this triangle as DEC, I can move ahead. Let's move on and draw a rough diagram of what we can see over here. As the height is constant, so this height here 87 would also mean that it's 87 meters here. Now, this angle is 60 degrees. So, first of all, we'll calculate the length of this CE, and moving ahead we'll calculate the length of CB and then subtract them. Well, for this triangle DCE, the tangent of 60 should be equal to the perpendicular divided by the base, that is DE by CE. Now I know tangent of 60 is root 3 and DE is 87 meters. So the length of C will be equal to 87 by root 3. 87 can be written as 29 into 3, and when I cancel this out, I get 29 into root 3, which will be 50.228, which you can write as 50.23 meters. Now coming to this triangle ABC, we know that the tangent of this angle 30 degree in context would be the perpendicular divided by the base, that is AB by BC. Now I know the tangent of 30 can be given by 1 root 3, so it should be equal to AB, which is 87 by BC, which means BC would be 87 into root 3. Now I'll get this by so the length of BC is equal to 150.684 or 150.68 meters. Now we are supposed to calculate the distance between D and A, which will be equal to the distance between B and E. Now we can calculate B by CB minus EB. So B, which is equal to AD, is equal to CB minus CE. So B would be equal to CB, which is nothing but 150.68 meters, subtracting the value of CE, which is 50.23 meters. I get 100.45 meters. This is the lateral distance that this balloon covers in the time that its angle of elevation changes from 60 to 30. Moving on to the next problem. Moving on to this next problem, it says that a straight highway leads to the foot of a tower, and a man standing at the top observes a car at an angle of depression of 30 degrees, which is approaching the foot of the tower with a uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degrees. Find the time taken by the car to reach the foot of the tower from this point. It means that there is a tower of some certain height. When the man looks down at the car, which is coming towards it, the angle of depression at this point is found to be 30 degrees. And after 6 seconds, it reaches this point here, where the angle of depression is found to be 60 degrees. Now we are supposed to find how long it would take for the car to reach from this point to the foot of the building here, considering they are all on even ground. Now let's name this as ABC, this as ADE. Now for a bit of ease in this problem, let's just take the height of the tower to be some arbitrary value, that is, let's say 10 meters. Now when the car is at point D, how far is it from this building that we have taken the value as 10 meters? Now in the triangle AED, the tangent of 30 would be the the perpendicular divided by the base. Now if this height of the building is 10 meters, so would this perpendicular distance be. This means that tan of 30 will be equal to DE divided by the base, that would be AE. Now tan of 30 is 1 by root 3. If you don't know how I got this value, so instantly go back to our channel Midha Guru, subscribe and watch the video Trigonometry part 1 and 2 to understand how you can calculate the trigonometric ratios of some specific angles very easily. Also, leave a like and comment on this video. Moving on. Now, I know that D is equal to the height of the tower, so I write that down as 10. Now, AE would be equal to 10 into root 3, that is 17.32 meters. The length here is 17.32 meters. Moving on, if I can just draw the rough diagram again. This was 30 degrees, this entire angle was 60 degrees. This length we calculated as 17.32 meters. This height here is 10 and also this will be 10. Now I know that the car is at a distance of 17.32 meters when the angle of depression is 30 degrees. When it comes to this point where the angle of depression is 60 degrees, this would mean that the tangent of 60 would be the perpendicular BC divided by the base AC. Now I know the tangent of 60 is root 3. BC is same as the building, so it would be 10 divided by AC. So AC will be equal to 10 divided by root 3. To solve this, I will get so the length of AC is roughly equal to 5.6 meters. That is, this length is 5.6 meters. Now, what is the distance CD or BE that the car moved? It is equal to 17.32 minus 5.6, which will give me So in this particular question, where we assume the building to be 10 meters, it moved a distance of 11.72 meters in 6 seconds. So the speed of the car is 11.72 divided by 6, which will be roughly equal to the car is moving at a pace of roughly 1.96 meters per second. So from this point B, how much time would it take to reach this point here, that is right at the foot of the building? Distance here is 5.6 meters. So we can calculate that the time will be equal to the distance divided by the speed, that is 5.2 divided by 1.96. roughly equal to 2.65 seconds. So from this point B, at which the angle of depression was found to be 60, the car will take approximately 2.65 seconds to reach the foot of the building. Moving on to the next example problem. Now coming to this last question, it says that the angles of elevation of the top of the tower from 2 points at a distance of 4 and 9 meters from the base and in the same straight line with it are complementary. Prove that the height of the tower is 6 meters. Let's say this is my tower right here of height h meters. The first distance is at 4 meters. Let's say that it makes an angle of theta 1. Second is at a distance of 9 meters. Let's say that angle is theta 2, but we know by the relation that it is complementary. Now if you don't know about complementary angles and how T ratios of complementary angles are related to each other, I would request you to please pause this video right here, go to our channel Midha Guru and watch Trigonometry part 1 and part 2 to clear all these concepts so that you can understand better how to solve this problem yourself. Also like and subscribe to our channel. Moving on. Now as this says that it is complementary, I will write this down as 90 minus theta 1. Now, if I name these triangles as ABC and ABD respectively, in triangle ABC the tangent of theta 1 is h divided by 4. Which means h is equal to 4 times of tan theta 1. Leaving it at that. And coming to the triangle ABD, the tangent of this angle 90 minus theta 1 will be h divided by 9. Now we know that the tangent of 90 minus any angle is equal to the cotangent of that angle. So now h is equal to 9 into the cotangent of theta 1. If I mark this equation as 1, this as 2, and I multiply 1 by 2, I will get that h into h is equal to 4 times of tangent of theta 1 into 9 times the cotangent of theta 1. H square is equal to 36 times tan of theta 1 into the cotangent of theta 1. But we remember that we can write cotangent as the reciprocal of the tangent function. Cancelling this out, we get that h square is equal to 36. So h would be the root of 36, that is 6. Now h is the height of this building, so the negative value won't stand here, which means that the height of the building is equal to 6 meters, and that is exactly what we are supposed to prove. Well students, we have come to the end of our lesson, and this completes the part of the chapter Trigonometry. But if still you have some doubts, not only related to this video, but relating to any part of trigonometry, please let me know in the comments down below. Subscribe to our channel, like this video, and join the family today. Thank you.